Hello student, welcome to all of you in your physics lecture. This is the video number 12, chapter number 1, rotational dynamics, and we have to see here the last topic, the law of conservation of angular momentum. Previous lecture we have to see here the angular momentum and the relation for the angular momentum L is equal to I omega. This is very important, and you can ask the questions, state and prove the law of conservation of angular momentum. In your exam, this question is repeated. State and prove the law of conservation of angular momentum. First, you have to remember what is meant by the angular momentum. So that we have to prove this angular momentum L is equal to I into omega. Very important relation. Now, we have to state here the law of conservation of angular momentum, and statement is there. If no external torque act on the rotating body, no external torque is very important. If no external torque act on the rotating body, then angular momentum of that body, it should be remains constant. It should be remain conserved. This is the law of conservation of angular momentum. Here again, if no external torque act on the rotating body, then angular momentum of that body remain constant. That means if torque is not act on that rotating body, then the angular momentum of that body, it should be conserved. It should remains constant. This is the law of conservation of angular momentum. Therefore, we have to see here the proof. We know that the angular momentum of the system is given by, we know this formula, L bar is equal to R bar cross P bar in vector form. What is the R bar? R bar is the position vector from the axis, and P bar is nothing but the linear momentum. You have to difference in between the linear and the angular momentum. This is where this P is the P is the linear momentum and L is the angular momentum. We have to see here L bar is equal to R bar cross P bar. R is the position vector and P bar is the linear momentum. Then, to prove this law of conservation of momentum, we can differentiate this equation. L bar is equal to R bar cross P bar. Differentiate with respect to time. Then, we get dl bar upon dt is equal to d by dt of R bar cross P bar. We have to differentiate with respect to time. Therefore, d by dt of R bar cross P bar. By using this chain rule, we can write here dl bar by dt is equal to R bar cross dp by dt plus dr bar by dt cross P bar. This is the differentiate with respect to time. That means R bar cross dp bar by dt plus dp bar by dr bar dt cross P bar. Then we have to see here this dr bar by dt is nothing but the v bar, rate of change of displacement with respect to time. This is nothing but the velocity. Therefore, we can write here dr bar upon dt is nothing but the v bar, and dp by dt, this is nothing but the force, that is the f bar. Then substituting this value in above expression, we get dl bar upon dt is equal to R bar, and dp by dt is nothing but f bar. Therefore, R bar cross f bar. Again, this dr bar upon dt is nothing but v bar. Therefore, we can write here v bar cross v bar, because this P bar is nothing but what? This is the product of mass and velocity. Therefore, instead of P bar, we can write here m into v, and that we take here v bar cross v bar, and m is as remain. This is the scalar quantity, mass is. Therefore, we can write simply m. Therefore, we get dl bar upon dt is equal to R bar cross f bar plus v bar cross v bar into m. But this v bar cross v bar is equal to 0, because this is the vector form. V bar cross v bar, this is nothing but equal to what? 0. Therefore, 0 into m, this term is 0. And therefore, we can simply write here dl bar upon dt is equal to R bar cross f bar. And we know that this R bar cross f bar, this is nothing but the torque. This is the product of force into moment arm, force into perpendicular distance. This product is nothing but a torque. We know this in 11th standard, moment of couple or torque. We have to see here, torque is nothing but it is the product of force and distance, that is the moment arm. Therefore, we can write R bar cross F bar is equal to torque denoted by the letter tau. Substituting this tau, we can write here dl bar upon dt is equal to tau bar. This is the very important equation. dl bar upon dt is equal to tau bar, that is the torque. But according to the statement, no torque is act on the rotating body. If no torque act on the rotating body, that means torque is equal to 0. And so that instead of this torque, we can substitute 0. Therefore, dl bar upon dt is equal to 0. And also we know that the property, the differentiate of the constant quantity, it should be equal to 0. That means the differentiate quantity, that L bar, it should be constant, and therefore the angular momentum of that body, it should be remains constant when, only when this torque act on that body is equal to 0, and this is the proof of the law of conservation of angular momentum. We can prove here this angular momentum, it should be remains constant, but when, if the no torque is act on the body, that means torque is equal to 0, then the differentiate of that quantity, it should be equal to 0, that quantity should be conserved, constant. Therefore, we can write here L is equal to constant. This is the proof of law of conservation of angular momentum. This is asked the question in board paper, state and prove the law of conservation of momentum for 2 marks. Then you can write the statement and all this mathematical state, and finally prove this L is equal to constant or conserved. Then your proof is complete and you get the 2 marks. Also asked sometimes what are the applications of this law of conservation of angular momentum. Then this principle of conservation of momentum, which can be the use in a sports like the ice skating, ballet dancer, then diving in the swimming pool, etc. This principle of conservation of angular momentum is realized in that example. And this is this point, law of conservation of angular momentum. In this chapter, the last point is the moment of inertia of the different bodies with the different axis of rotation. In your book, there is also a table with diagram, but in this table we can write just object, then how that axis, and what is the moment of inertia. Some objects are here and we can write directly the formula for the mi of that body. We can remember this in your numericals and so CT, JEE, NEET exam. These formulas are very important. First object we have to take here, the ring. This is the thin ring, suppose which can be the passing through the central of this axis. Then the moment of inertia I is equal to mr square. Then you have to remember these terms and conditions, thin uniform ring which can be passing through the central axis, then its mi is mr square only. But this thin uniform ring which can be the passing through along its diameter, then the mi of this ring is equal to 1/2 mr square. This is given by this principle, parallel axis and perpendicular axis. This we can find out, but just you have to remember this formula for your numericals and your computer exams. The thin ring, central axis, I is equal to mr square. Passing through its diameter, I is equal to 1/2 mr square. Same way, the another object we have to take here, the uniform disc. Then again, the uniform disc passing through its central axis, then its mi is given by I is equal to 1/2 mr square. Uniform disc passing through the central axis, then the mi is equal to 1/2 mr square. If you have to passing through its about its one diameter, then its mi I is equal to 1/4 mr square. This is the formula for the uniform disc central and diameter. I is equal to 1/2 mr square, and for diameter axis I is equal to 1/4 mr square. Next object is the hollow sphere. If the sphere is hollow, then passing through its center axis, passing through its center at perpendicular to its plane, then its mi is given by I is equal to 2 by 3 mr square. If you have to consider the hollow sphere passing through its center perpendicular to its plane, then I is equal to 2/3 mr square. If you have to consider the, instead of hollow sphere, a solid sphere, and which are passing through its center axis and perpendicular to its plane, then its mi is given by I is equal to 2 by 5 mr square. Then next subject we have to consider here the thin uniform rod, and which are passing through the center and perpendicular to its length, then its mi, thin uniform rod passing through its center and perpendicular to its length, which is given by I is equal to ml square by 12 or 1/12 ml square. This is the mi for the thin uniform rod. Also, this thin uniform rod which are passing through its perpendicular its length and passing through the one end of the rod, not passing through the center, but which is passing through the one end of the rod, then its mi is given by I is equal to 1/3 mr square. This is the mi for this thin uniform rod, but which is perpendicular to its length and passing through the one end of the rod, then I is equal to 1/3 mr square. This is the formula for the different objects of the or bodies passing through a different axis of rotation, then mi is given by. Also, you can just give the assignment for on this table. You can draw the diagram for this ring, uniform disc, sphere, rod. You can draw the diagram also, and also find out the radius of gyration. For example, you know that the radius of gyration is given by k is equal to under root I by m. Then instead of I, you can substitute this I, mr square. If you have to disc, 1/2 mr square, sphere 2/3 mr square. Instead of I, you can substitute this value and divide throughout by m, and taking the square root, then you can find out the radius of gyration. In MCQ, you have to ask the radius of gyration of any body like this ring, disc, sphere, rod, etc. So that you can you give this radius of gyration, then this is also used in your numericals, and this is very important. In this way, in this rotational dynamics, we can learn a lot of points, and this is the last one, points: moment of inertia of different bodies with the different axes of the rotation. And we can end of this chapter, rotational dynamics. In next lecture, we can see the next second chapter, and you can solve the numericals on this topic, rotational dynamics. I give the some MCQ, some assignment, 1 marks, 2 marks question in your WhatsApp. Okay, thank you.